Okay, so I'm going to try to finish up these problems here, starting with number 37. Okay, so it says, what is the total area of the shaded regions? And it also keep important information. Each vertice is at a midpoint in the side of the shaded square, so that means that all of these are congruent sides. Okay. All right. So first off, the fact that this is 90 and those two are congruent makes this a 45, 45, 90. So if this side is 3 square root 2, these would be 3 and 3. Okay. So that basically means that one side length of this square is 6. So if I want to get the area of the shaded region, I'm going to subtract the big square minus the little square. Okay. All right, so big square would be 6 times 6 to get an area of 36. Little square would be 3 square root 2 times 3 square root 2. Okay. So you can just put 3 square root 2, close the parentheses and square it, just like I did here. Okay. And then that'll give you that the area for the smaller one is 18. So you subtract them. 36 minus 18 is 18. Okay. Okay. So next, a carpenter is remodeling a house and needs to cover one side of a staircase in a landing with sheetrock. The figure at the right represents the area to be covered, which is made up of a rectangle and right triangle. What is the total area of a figure? So this is composite area kind of problem. Okay, so first off, 4 times 6, okay, will give us an area of 24. So the idea here is that we need to add the area of the rectangle to the area of the triangle. Okay. Since this is a rectangle, that length would also be 4. You're going to need to use SOHCAHTOA in order to get the base here. So this is our opposite side. This is our adjacent side. Okay, opposite adjacent. So this is x. So opposite adjacent goes with tangent. So we'd say tangent of 25 is equal to 4 over x. Since x is in the denominator, we're going to divide. So x is equal to 4 divided by the tangent of 25. Which is equal to 8.58. Okay. Okay, so since we're only getting area and we're not worried about perimeter, all we need here is the base. Okay. Area of a triangle is 1/2 base area, or sorry, just base times height. Okay. So then that would become 1/2 8.58 times 4. So that's equal to 17.16. Okay. All right, last step, we need to add these two areas together. So 24 plus 17.16 is equal to 41.16. All right. Okay. Tara took a sheet of paper and measured 8.5 by 15. Oh. Okay. So the picture is 8.5 by 11. This is 8.5 by 15. Let's just ignore this and go by the picture. Let's say that it's 11. Okay. She tore off a piece in the shape of an isosceles triangle. That's important. These sides are congruent. What is the area of the remaining paper? So you're going to have to take the area of the rectangle and subtract the triangle in order to get what's left. Okay. If this is an isosceles triangle, then if this is 8.5, so is that. So for the rectangle, 8.5 times 11 would give us an area of 93.5. And then for the triangle, 1/2 base times height, 0.5, 8.5 times 8.5 would give us 36.13. All right, and then we just subtract 93.5 minus 36.13. and that's equal to 57.37. Okay. Next problem. The perimeter of a rhombus is 40, and the longer diagonal is 16. What is the area of the rhombus? Okay, so the reason that it's talking about diagonals here is because the formula for area of a rhombus is diagonal 1 times diagonal 2 divided by 2. So this is our end goal. We need to get the two diagonals. It already tells us that one of our diagonals is 16. So let's say that that's this one, okay? This is telling you that this is getting split in half, so 16 divided by 2 would mean that each piece would be 8. Okay? All right, we need to get the other diagonal, this one. It tells us that the perimeter of the rhombus is 40. All sides are congruent, so 40 divided by 4 would mean that each side has a length of 10. Okay? All right, so the way that we can get the other diagonal is by using Pythagorean theorem here, okay? So the square root of 10 squared minus 8 squared is equal to 6, okay? So diagonal 2 would be equal to 12. Last step, let's plug them in. 16 times 12 divided by 2 gives us an area of 96. Okay, two given squares are similar. The side length of a smaller square is 6 times the side length of the larger rhombus. How many times bigger is the area? Okay. Wait a minute. So, okay, two squares are similar. This is x, this is 6x. Side length. Okay. This wording is a little weird here, but I'm pretty sure that this is the kind of picture that they're talking about. So it's basically saying that one side length on the smaller square was multiplied by 6 to get this side length for the larger square. It's asking how many times bigger is the area. So remember that area is a two-dimensional thing. This is going to get multiplied by 6, so is this side. When we solve for area, we multiply two sides together, right? So the area of the original would be x squared. If we multiplied the area of the new one, okay, notice not only do the x's get multiplied, but each scale factor gets multiplied. So the new area would be 36x squared. So what this basically means is that whenever you're dealing with area and you're looking at how it changes, you need to square the scale factor to get how many times larger is the new area. So the new area would be 36 times larger than the old one. Okay. Number 42 is another area problem for a regular figure. These are a lot like the one we did back here. Okay, actually it's exactly like the one we did back there. It's just a different shape. So, formula is 1/2 AP. A stands for apothem, P stands for perimeter. So first thing you're going to have to do is find your apothem. Okay, tells us that each side is 8 inches, so we probably want to include that information. That means that this piece here would be 4. We need to get this angle. We're going to do that using this formula, 180 times 8 minus 2 divided by 8. And that's equal to 135. Divide that by 2, and that's equal to 67.5. Okay, so 135 is the measure of one interior angle. We divide that in half to get the measure of the angle inside of the triangle. I'm going to create a little bit of a bigger picture out here so you can see it better. Okay, so this is 4, this is 67.5, this is A. Okay, we're going to use SOHCAHTOA to get A. So this is the opposite side, adjacent side. So tangent of 67.5 is equal to A over 4. A is on top, so you're going to multiply. The apothem is equal to 4 times the tangent of 67.5. So that's equal to about 9.66. Okay, and that's when we're in degree mode. Okay. Okay, so then let's see. After that, our perimeter is equal to 8 side length, a side length of 8, and we've got 8 sides. So 8 times 8 is equal to 64. Okay. Our apothem is 9.66. Okay. Now we're about ready to get the area. So last step, plugging things in, we've got half apothem, which is 9.66, times perimeter, which is 64. And that's equal to 309.12. That's our area. Okay. Next. If Paul places a glass sphere which has a radius of 3 inches inside a cube-shaped box is shown, how much empty space will be left in the box? Okay. We had this, it was a test problem, so you got to take the volume of the cube and subtract the volume of the sphere, and that gives you what's left. So for the cube, 6 times 6 times 6, so 6 to the 3rd power is equal to 216. Okay. For the sphere, formula is 4/3 pi r cubed, and our radius would be 3. So we would have 4/3 pi times 3 to the 3rd. Okay, so that's about 113.097. So let's round that to 1. Okay. Okay, so now we just subtract them. Minus 113.1. So the leftover space is 102.9. Okay. Next, a storage container is made from a cone placed on top of a cylinder as shown. If all outside surfaces except the part which rests on the ground will be painted, about how much surface area in square meters will be painted. So essentially what this question is asking is it wants you to find the total lateral surface area for the composite figure. So the lateral surface area for the composite figure. So you're going to have to get 2 formulas. Okay. So for the cone, okay, lateral surface area is pi RL. Okay. For the cylinder, lateral surface area is 2 pi RH. And you're going to have to add those together in order to get the composite. So looks like we're going to have to solve for our slant height here. So I would get the height, this height, by taking 22 and subtracting 7. Okay. So that gives us, this is a height of 15. And then if this is 16, that means that this length would be 8. And then I can use Pythagorean theorem to get the slant height. So the square root of 15 squared plus 8 squared gives us the slant height is 17. Okay, so pi times 8 times 17 is equal to 427.26. Okay. And then next we have 2 pi RH, so that's 2 pi, and then this is for the cylinder, not the cone, so we want to use the radius of the cylinder, 8, and the height of the cylinder, which is 7. Okay. So 2 pi times 8 times 7 gives us 351.86. Okay. Last step, we need to add these two. So 427.26 plus 351.86 is equal to 779.12. Okay. All right, 45. What is the total surface area of the prism shown? So total surface area of a prism, the formula is pH plus 2b. P stands for perimeter of the base, B stands for area of the base. If we're going to get those things, we're going to need to solve for these other sides. So you saw I put a 7 here because if this is 7, then that's got to be 7. Okay. We're going to have to use SOHCAHTOA again to get these two other sides, x and y. Okay. So this is our opposite, this is the hypotenuse, this is the adjacent. Opposite and hypotenuse goes with sine. So sine of 30 is equal to x over 7. X is equal to 7 times the sine of 30. So that's equal to about 3.5. Okay. If you wanted, you can use SOHCAHTOA here. If you're confident in your answer, then you could use Pythagorean theorem. So 7 squared minus, 7 squared minus 3.5 squared. Okay. That gives us about 6.06 for the other one. Okay. All right, so for P, we need to add up those sides. So 3.5 plus 6.06 plus 7 is equal to about 16.56. Okay. And then B, 1/2 base, 6.06 times height, 3.5. That's equal to about 10.61. Okay. All right. Last step, we need to plug everything in. So we've got 16.56 times the height of the prism this time. This H stands for the height of the prism if it's standing on its base. And remember, in a prism, the bases are the two shapes that are parallel to each other. So the triangle is the base, which means that the height would be 7 plus 2 times area of the base, which would be 10.61. 16.56 times 7 plus 2 times 10.61 is equal to 137.14. Okay. A food vendor sells juice in a cone-shaped paper cup. Which of the following is closest to the maximum volume of juice that this cup can hold? So, volume of a cone, formula for that is 1/3 area of the base times the height, 1/3 BH. Okay. Also, side note, in a cone, the base shape is a circle, so you want to replace that B with the formula for area of a circle, which is pi r squared. Okay. Our diameter is 3. Divide that in half to get the radius of 1.5. So we have 1/3 times, times pi, let me write that better, 1/3 pi times 1.5 squared times the height of 5. That's equal to about 11.78. Okay, and that's our volume. If you wanted to write the units, that would be in inches cubed. This is volume. Lateral surface area of the square pyramid. So pyramid lateral surface area is half PL. Okay, this one shouldn't be too bad. So it's a square pyramid, meaning that to get the perimeter, each of these sides is 12. Okay, so 12 times 4 gives us a perimeter of 48. They very nicely gave you your slant height already, so we don't need to solve for this. So it would be half 48 times 10, and that's equal to 240. Okay. All right. Next one. Miss Ariaja uses a kitchen knife and an orange to demonstrate to his students, Mr. Ariaja, to his students how a plane might intersect a solid object such as a sphere. Which of the following will result in the same kind of cross-section? Okay, so cross-section is when you take a 2D shape, you slice it, and you take a 3D shape, you slice it, and you look at the 2D shape that's formed by the slice. So in this case, our cross-section is a circle. Okay, so we're looking for which one of these, when you cut it, would also create a circular cross-section. So it's not going to be the pizza. It's not going to be the board, because that's obviously a rectangle. This one, they're cutting the cone down through the top. So the cross-section that would be formed here is actually a triangle. When you opened up that cone and looked at the two shapes, that would be a triangle. The cylinder, though, when you take a cylinder and you chop it through like this, it's going to mimic this circular base. So the cylinder would also have the circle. Next, write the 3D solid that would be created if the figure were rotated about the line. So this is 3D rotations. Okay. So you have to imagine that every point on this line is getting rotated around in a circular motion around this line. So like this is all coming around, spinning like this. So when that happens, this forms a cone shape. Okay. For the sphere, you can imagine again all of these points are rotating around. Doing my best to draw this here. Okay, rotating and rotating and rotating. So this ends up creating like a spherical kind of shape. Okay. And then for the rectangle, again, these are rotating in circular motions. So it's going to form this like circular here. And then these are all getting rotated. This whole line is getting rotated. And then this is getting rotated around. So the shape that it kind of forms is a cylinder. Okay. All right. We are on the last page. Nice. So it says, given the center of a circle is 3, -2, and the diameter is 10, what is the equation of a circle? So the formula is x minus h squared plus y minus k squared equals r squared. H and k represent your center. This is the center coordinate. And then, of course, r is your radius. So if our diameter is 10, that means that our radius would be 5. Plugging it in just raw, it would be x minus 3 squared plus y minus a -2 squared equals 5 squared. Your answer choices are not going to be written like this. They're going to be simplified. So this simplifies down to look like this. X minus 3 squared plus y minus a -2 becomes y plus 2. And then you want to go ahead and square this. 5 squared is equal to 25. So this is the format that you'll see the equation written in. Okay. This time around, it gives you a circle and the endpoints of the diameter. So you have to do two things. You have to, one, get the midpoint of those two things in order to get the center for the circle. Because if those are your diameter endpoints, come to the middle and that's the center of the circle. 2, you need to get the distance and then divide it in half to get the radius. Okay? Alright, so midpoint formula says that we add our x values and divide by 2, and we add our y values and divide by 2. So negative 11 plus 7 divided by 2 would give us negative 2. Okay. And then 21 plus negative 3 divided by 2 gives us 9. Okay, so this is the center for the circle. Next, distance formula, and this formula is on your chart. So it says distance, x2 minus x1 squared plus y2 minus y1 squared, take the square root. Okay, so plugging things in, see, I like to write it out first. This is our x, y, y, so it would be negative 11 minus 7 squared plus negative 3 minus 21 squared. Alright, now I can type it into the calculator just like that. Negative 11 minus 7 squared plus negative 3 minus 21, close parentheses, squared, and that's equal to 30. Okay, that is the diameter. We need to take that and divide by 2 to get that the radius would be 15. Okay. All right, now you have everything that you need to plug it into the formula. So the last part, it should be relatively easy. Taking things and plugging it in, x minus a negative 2 becomes x plus 2 squared, y minus 9 squared equals 15 squared, which is 225. So this is our equation. Okay. Arc AC is intercepted by a 130-degree central angle. What is the area of the sector? So this angle right here is 130. All right, so the formula for area of a sector, and you do have this on your formula chart. Grab it. Sector area. So this is a formula that they use, the measure of arc AB over 360 times pi r squared. That's fine. That formula is perfectly fine. Personally, I like to call this angle theta. This is the same thing as the measure of arc AB. I just call it theta. Okay. And then I put everything together on the top, because if you do this times pi r squared, it's the same thing as doing this times pi r squared and then dividing by 360. This formula is my preference, but they're the exact same thing. Okay. Okay. So using this formula, I plug in the 130 pi, my radius squared, over 360. And part of the reason I like this formula is because I can just do everything in one step and not have to worry about multiplying afterwards. So 130 pi a squared divided by 360 gives me that my area is about 72.61. Done. That's the area. Okay. Next, it wants to know the length of AZ given that the perimeter is 28. So the key to solving this problem is there's a theorem about circles that says that when you have two tangent lines that come from the same outside point, these segments will be congruent to each other. So if this is 2, that will be 2. If that's 1, that will be 1. That's 2, that's 2. If that is 3, that is 3. And then those two pieces will be congruent as well. Okay, so what we can do is we can add up what we have so far of the perimeter, subtract it from the total perimeter, and then divide it by 2 to split it between this side and this side. Okay. So let's add them up. 2 plus 2 plus 1 plus 1 plus 2 plus 2 plus 3 plus 3 here and here. Okay, that gives us 16 as what we have so far. Okay, that's subtracted from the total perimeter of 28. And so that gives us what's left is 12. And then we got to split that between here and here. So 12 divided by 2 would mean that each one of these is 6. Okay, so that's your answer. Okay, what is the measure of arc AB? So if it's asking for the measure, and it's not asking for the length, measure is in degrees. And really, it's just knowing that the central angle, okay, is going to match the measure of the arc on the circle. So the arc would also be 40 degrees. Okay. All right, problem number 55. What is the value of x? So let's see. We have a tangent line and a secant line. We're going to be using this formula here, t, and then we've got y and z, so it says t squared is equal to y times y plus z. You do have this on your formula chart, theorem 6. Okay, so we would say that 6 squared is equal to 2 times 2 plus x. So 6 squared is 36. So there's kind of two ways you can do this. I guess I'll do it this way first. So we can distribute that. So that become 4 plus 2x. Subtract 4. We get 32 is equal to 2x. Divide by 2. We get that x is equal to 16. Okay. Okay. For this one, I'm kind of running out of room, so I'm going to do a little bit more on this paper. Okay. So this is similar, but it's a little bit different because it's 2 secants this time. It's the same theorem, but it's part 2. So it's going to be the one that has 2 secants, where you've got w, x, y, and z. So w times w plus x equals y times y plus z. Okay. All right, so plugging things in, that becomes 2 times 2 plus 16 is equal to 4 times 4 plus x. Okay. All right, so 2 plus 16, do what's on the parentheses first. This is 18. Okay. 4 times 4 plus x. 18 times 2 is equal to 36. Okay. So I'm going to do it the other way this time. So if you don't want to distribute, then what you can do instead is you can divide by the outside number. So divide by 4. Those will cancel. 36 divided by 4 is 9. And that's equal to 4 plus x. And then subtract 4. 9 minus 4 is 5. So x is equal to 5. Okay, the bell's about to ring, so let's see if I can do this in 2 minutes. So, okay, next one, we've got 2 chords, one that has 3 and 12 and one that has 9 and x. This goes with part 1 on theorem 6. So based off of this picture, the numbers that you should multiply together are the numbers that are on the same line. A and B are on the same line, and C and D are on the same line. So that means that we are going to multiply 3 and 12 together. And we're going to multiply 9 and x together. All right, so 3 times 12 is equal to 36. That's equal to 9x. Divide by 9. So x is equal to 4. Woo, almost done. Okay. What is the value of x in the figure? So this angle right here, this is an inscribed angle, and we can tell because its vertex is sitting right on the edge of the circle. There's the bell. Okay. I want to point out, you do have this theorem on your formula chart. It's the very first one. It says that the measure of angle B is equal to half the arc AC. So for example, if this was 80, and then this would be 40. Okay. All right. So what we can do here is we can get this arc first. Okay. We can do that because we already have the other arcs on the circle, and we know that a full circle is 360. So I would add 82 plus 60. That's equal to 142. Okay. And then 360 minus 142 is equal to 218. Okay. So that's the measure of this arc here. And then since this angle is inscribed, I just divide it by 2. So 218 divided by 2 gives me that x is equal to 109. Okay. All right. So these last two problems, these were on last year's final. They're not going to be on this year's final. These two questions are going to be replaced with a circle question and a question that's about Pythagorean theorem, which we've already done some examples for that. Now, just if you're curious, I'll go ahead and show you that. So it says, how many ways can 5 people sit in 5 different chairs? So the answer just so happens to be 5 factorial. And a factorial, what that is it means to take that number and multiply it by every number that comes before it. So 5 times 4 times 3 times 2 times 1 is 120. Okay. And also, just FYI, you do have a button on your calculator that can do factorials for you. So, like for this next problem, it's the same kind of thing, but instead it's going to be 7 factorial this time. So you can go type in 7. Let me zoom out a little bit so you can see. You press math. You go over to where it says PRB. This stands for probability. And then you see your exclamation point, the factorial. Hit enter. And we get that that's equal to 5,040. Okay. Sometimes it's kind of fun, like just to me, to see if you can, like how far you can get. Like there's 52 cards in a deck, so you can see what 52 factorial looks like. The numbers get very large, by the way. So large that if you tried to do something like 120 factorial, your calculator can't even do it. It's too large of a number, and your calculator can't handle it. So I just think that's kind of cool. Okay, so that's it. That is everything that is going to be on the final. I wish you the best of luck, and it's the last test you're ever going to have to take for geometry. So good luck.